Now we are going to do June 17, paper 34. Look at this diagram. We are going to do this practical in a few minutes. Now, you have two stands. You have the spring here with a small string here. We have a loop here. You have to put the two string on the rod here on both stands. Then you have to measure this. You put the mass hanger. You put the mass hanger. Okay, you put the mass hanger. Then you measure the angle 165. Then you keep it here. You put two clamp on the stand to secure it because it will remain like that during the experiment. Don't forget that this height, the rod from the bench, is 50 centimeter. Now you have to change the mass here and to make small oscillation. Okay, 100 gram, 150, 200, 150, up to 400. You have to put the mass here and perform small oscillation. Now the precaution here is these two. Before putting any other masses, when you have finished to put the mass hanger on it, you have to measure this 165. Okay, now I will show you how I do it. A few seconds. Okay. Now, here, you have two stands. You have to make sure that the rod is 50. Okay. If it is not 50, you adjust it. Okay. Now, this is the string, the loop, and the two springs. So you put the spring here and put the spring here. For the heights, okay. Now for the angle now, you have to put the mass. Only the mass angle. Okay. Now you have to make this angle become 165, about 165. Not exactly. Put it here, put the stem. So you put your now it's okay. Then you measure this angle. Okay? Yeah. You put the center of the protector, the center here, with the knot here. Then you take one side on this with this string, and you measure the angle you make with the other string. Now it is 165. Now you put the mass. Now you have to secure with the G-clamp. Okay. How to secure with the G-clamps. Because the height, the stem should not move during the experiment. Then you bring the two string here, not in the end of the rod. It will fall. You bring it in the middle. Then you put the mass. Okay, and then you perform small oscillation like that. Then you take the oscillation. Then you will notice that the oscillation is rapid because of the strain. Now 20 oscillation, the oscillation will be fast. Uh, I don't recommend you to take 20 oscillation because 20 oscillation will be about 10 seconds or 12 seconds. So for a good reading, it should be about 18, 19 or 20 or 25 seconds. So you take more oscillation. You take about 30 oscillations. Okay? Ah, good. Now, don't forget that when you put the mass, you have to record the height. Yeah. You put the step, you put the meter rule on the table, then on the bench, then you measure the height. It is 24. You have to record the mass, you have to record the height, and then the time for oscillation. Then you perform 2 oscillations. Okay, then you have your result. Okay, good. Now, what you have to do, you have to put the 250 gram, okay, you take the height, and then you calculate T. So I have taken 30 oscillation. Why 30 oscillation? Because if I take 20 oscillation, the time will be too low. Okay, this is why I have taken 30 oscillation. 17 to 20, okay. So this is why I have taken 30 oscillations. Then I have approximately 0.2. Okay, now you have to change the mass. So this is the sample 250 that we have done. I have taken 200, 150, 100. 2 free readings below 250 and 2 readings above 250. So in all, I have got 6 readings. This was the height. For all, I have taken 30 oscillation. And these are my reading T1, T2, average T and T. So average T divided by 30, we get this value. And to the power of 3, we get this. Okay. Now I have rounded the figure. Can you see I have rounded the figure? So that I can plot them. Now we are going to plot T cube on the y-axis and H on the x-axis. Cambridge tell you not to convert it to meter. Let it be centimeter. Look in the marking scheme. I could have convert this centimeter into meter as usual, but Cambridge want to see whether you have a 0.2. You have taken the reading to nearest millimeter. Okay, so look in the marking scheme, you will get a better idea about that. Okay, this is why I have put it centimeter. There's nothing wrong in it. Okay, now let us see the graph. Let us see the graph. This is a graph. The H in the H value, 1 minute. I have to show you the H values. So the H values start with 17.6, 28.2. 28.2, 17.6. So how to plot 17.6, 28.2 in the x-axis. So 17.6 here. So I start, we cannot plot the graph here. We cannot plot along the x-axis and y-axis. So I started here, one value before. So 17.6 here, 16 here. So the difference is 1.6. You can see, so 16, 1.6 become here, 1.6 become here, like that until I reached 28.8. So the last reading is between 27.2 and 28.8 because it is 28.2. So for the y-axis, it is like that. The y-axis, 0.1 to 0.3, 0.1 to 0.3. So I cannot start with 0.1. I start a little below 0.1. And I do not end with 0.3. I end with a bit more than 0.3. So for example here, I do not start my graph with 0.1. Look here, 0.1 to 0.3, okay? 0.1 to 0.3 on t cubed. Now 0.1, I don't start the graph with 0.1. I start it a bit higher. And then I don't end it with 0.3. I don't end it with 0.3. I end it with one more, which is 0.32. Otherwise, this point will be on the borderline. I don't want the point to be on the borderline. If 0.3 would be here, then the point would be here. No, the point should be in the middle. Can you see? The first point here and the last point, can you see they are all in the middle of the graph? They are not on the border here. Okay, so I start a little below 0.1, so I have chosen 0.08, and the difference is 0.02, 0.08, 0.02. I add 0.02, I get this. I add 0.02, I get this, and continue like that until I reach 0.32. So I'm happy with the y-axis. Don't forget to put your t cube here. Then I have done I have put the unit here. So I start to plot the point. Okay, I put a small dot, then I circle it. Now I have to draw the line of best fit. So I have preferred to pass through this point, 1 point, 2 points, 3 points on the line, and this one, and this one not on the line. So I have 1 point on that side and 2 points on the other side. So in my opinion, this is how you have to draw your line of best fit. Now, to be able to do the gradient now, to do the gradient, you have to do a construction line on your graph. Everything is written with pencil, okay? Now, you have to make a small arrow to indicate to the examiner the coordinate at this point, because we are going to use this point for the gradient. Now, it is like that. And this point also, I make a small arrow. I indicate to the examiner the coordinate of this point. Okay. After doing this, my graph is correct. I have to calculate the gradient. So I put the two coordinates that I have put with arrow on my graph there. Then I calculate the gradient. It is negative because the line is on that direction. Then I replace a point on the y and a point on the x, and the gradient I calculated here to get the y-intercept. Now for the gradient, you give the unit here, and this is a unit here. So don't forget that the gradient is negative. Let's have a look to the graph again. a line like that is the gradient is negative. Okay, so there is a negative gradient. Okay, good. Now for the y-intercept it is 0.63. But as you know, I have not started my graph with 0. I have not started my graph with 0. Otherwise, my graph would not be over a whole graph paper. So I won't have my y-intercept on the graph because I have not started with 0 down here. I have started with 0.08. So 0.63 would be somewhere here. If I continue the graph like that, 0.63 should be something higher up. So we can guess that our y-intercept would be correct. Okay, it is not absurd. Correct. This is correct. This is correct. This is how you have to present your work. Very tidy. And okay, now for the last part, you just have to compare it with the graph. So you will get A, which is the gradient, and B, which is the y-intercept. And this is the y, this is the h. So very easy. Okay, now we are going to do number 2. Okay, now in number 2, we given this apparatus. Okay, you will have to put you will have a tube here. You have to put the tube in water, and then there is a plumb line here, and then we have a mass here, a paper clips. Now when you arrange it, it should be horizontal. Then you will take when it is horizontal, you will have to bring the mass 4 centimeter to the right. Okay, then it will tilt. Then you have to take this angle. Then you take it 3 centimeter. Then you measure this angle. Okay, so let us see how it works. This is my apparatus. Now put it in the water here. Okay, so then I put the mass here until it is horizontal. See, it is not horizontal. Now here it is horizontal. Okay, you take this reading. Then next time you will have to bring it 4 centimeter on that side. You can see it tilts. Okay, then you measure this angle. How to measure this angle? You take your protractor. You put the center of the protractor with a nail. Then you align it with a ruler. There is a line. There is a line on the protractor and a small the center of the protractor. You bring the center of the protractor to the nail. Then the line on the protractor should be aligned with the center of the ruler. Then you measure the angle. Okay. Now, then you have to bring it. Say for example, it was 44 when it is parallel. Okay. Now you have to move it 4 centimeter to the right. So it becomes 48. Then you measure the angle here, this angle of inclination. Then you have to bring it 3 centimeters, so it is 47. Then you measure this angle. Then you will fit the angle and the distance in a formula to see whether the formula stands. Okay? Now don't forget that the height here should be 2 centimeters at the beginning of the experiment when it is horizontal. Like that, it should be 2 centimeter height. Okay? Okay, now let us see the theory report now. Now, this is x is 19. So what is 19 now? It is the center, this distance when it is horizontal, this distance minus 25. So 44 minus 25 is 19. Now here, it inclined, then you measure this angle. Now you take this distance, okay? So the distance now is 23 because I have taken 48 because it was 44. I brought it 4 centimeters, so it becomes 44 plus 4 centimeters, 48. So this distance is 48 minus 25. You note it here, okay? The angle I measured was 99, this angle. So the difference is 9 degree. Okay, theta minus 90, 99 minus 90. So the difference is 9 degree. So the percentage of certainty, the error you can make, it should be plus minus 2 according to the mocking scheme. So you take 2 upon 9 times 100, it is 22%. This is a very large uncertainty because Cambridge wants you to notice that it is a large uncertainty. So there's a larger margin of error in this experiment. Okay, now let us see the next. So page 9, you have to repeat it now with the, because it was 44 when it is horizontal. Look here. When it was horizontal, it is 44. Now you have to move it 3 centimeters here. So it becomes 47. Then you measure, it will tilt, then you measure the angle. So I got x now, which is the center 25 minus 47 minus 25, 22, angle 95. So the difference in angle is 5. Now let us play with this. Now, as usual, you have to fit the angle and the distance x and x naught. X and x naught is the original distance. Okay, so x naught in your formula for the two readings. Then what I have done here, only to show you that we can convert centimeter into meter and put in the formula. I have done it because this distance is in centimeter, but I don't like to put centimeter in formula, so I convert into meter. But in fact, Cambridge wants you to do it in centimeter, okay, not in meter. So when I did it in meter, I get 3 point, K here is 3.9 and here it is 2.9. But the same, in fact, you will get the same result at the end. So here I have done it again with 0.039. So I have put centimeter in my formula. So I get 0.039, here I get 0.029. So this is why I put it in red. Okay, if you want to work it with centimeter, you can do it because it is accepted by Cambridge. Okay, so I have worked it with meter. Now all measurement are theta minus 90 x or x minus x naught or all 2SF. Okay, 3.9, 2.9. For the angle, it is 23, 99. So all are 2SF. So this is why I work my value of K in 2SF. Okay, this is the justification here. Now what you have to do to support your answer, you have to judge the two values of K. So what you do, you take the difference between the two values of K and then you put it on the average of the value of K. So I take 3.9 plus 2.9 divided by 2. And this difference is 1. So 1 upon 3.4 times 100, you get 29%. So there is a 29% difference between the two values. So your question is whether the results support the suggested relationship. No, the result does not support the relationship because the percentage difference between the two values of K, the difference is 29%, which is not acceptable, which is much greater than 10%, which is acceptable. Okay, now let us do some quick. We carry on. Now you have to measure this. This is ruler. It is the here the diameter of the pipe. Okay, so you take a ruler, you measure it. So it is 2 and 1.5. The mass of the paper clip was given to be 10.79. Look here. On a piece of paper here, I have put 10.77 grams. So you record it here. Now to find the density of the pipe, you have to fit in this formula. So I fit it in my formula. I put the mass of the paper clip here. C, a constant given. My value of K, you are told to take the value of K with the smallest value of K. You take it, then you will get this density of the pipe. This is very good answer because this is very light. The pipe is very light. If you cut any area of 1 centimeter cube, it will be 1.1 gram. Okay. Now for the critics. Now, as usual, the first two readings are not enough to draw valid conclusions. So take more readings and plot a graph of sine theta minus 90 against x minus x to find K. You know the formula here. It is like y is equal to mx plus c. So this is y against this, and the gradient will be K. Okay. This is what I'm saying. Now for the second difficulty to measure angle. Why? It is very difficult to measure angle. There is a risk of parallax error because the protractor is a distance with the ruler, okay, and the line. So take a photograph and measure the angle on the photo. This is given by Cambridge itself. You have to take a photo in front and then you measure the angle. Or you can use distances like, then you use sine theta and cos theta is equal to opposite of an hypotenuse, things like that. Okay, this is acceptable. Now, difficulty to measure DOD, the diameter of the pipe. Okay, you get with a ruler, it is very difficult, so you use a vernier caliper. Now, this is the most important critics. Large uncertainty in theta minus 90. Because why you are told to do this? This is the question. Why you are told to do this? Where we use this in the question? So this examiner wants you to do. You have a percentage uncertainty, which is a reason for that. Because when you increase the distance here, there is an inclination and the degree we want to measure. Okay. Okay. Now what we have to do for the angle, uh, the angle is the percentage of uncertainty in the angle is 22%. Okay. So Cambridge tell you to measure the improvement is to measure theta by using more paperclips. Why? Because larger certainty in theta minus 90. So you have to use more paperclips. Why more paperclips? Because when you use more paperclips, then I think that here when you put the mass the pipe in the water, you have to use more paperclips so that this angle becomes more, because when this will be heavy, it will move in that way. Okay, then we can move it closer to the pipe. So here the you understand what I'm saying? Now it is lighter, so we have to put it a lot of distance. Okay, if it is heavier, we had to put it near, okay, for it to be balanced. Because if it is heavier, it is lighter. This is why we increase the moment. But it is heavier, we have to put it here. Then the angle would be more accurate, according to Cambridge. Okay, so this, if you get problem, I can explain to you in tuition. Okay, bye.